Today we're going to talk about interpreting parabolas. Now the graph always has coordinates that shows the relationship between two variables. When we look at our regular Cartesian plane, our coordinates tell us the location of our point. So for example, if we have 3, -5, it tells us that we've moved 3 units in the x direction and -5 units in the y direction. In this graph, we have the path of the water after exiting the fire hose. The coordinates are made up of the height and the horizontal distance. In this graph, we have the size of a garden and how the area changes as the length also changes. In this graph, we have the path of a launched rocket. It's made up of height as it is related to the time. Now let's look specifically at the coordinates of a point. This graph shows the height, h in meters, of a small rocket, t seconds after it's launched. So instead of having x and y, we're now talking about t and h. So I know that t is along my x-axis, that represents time, and y is now height, and that's represented in meters. So, first question, what does the coordinate 6, 190 tell us? Next question, what does the vertex tell us? Now 690, we know this is our time and this is our height. So that means at 6 seconds after the rocket was launched, it's at a height of 190 meters. What does the vertex tell us? So the vertex is 4 and 260. Once again, we need to consider 4 as the time and 260 as our height. So it tells us that the maximum height is 260 meters and it's reached 4 seconds after the rocket is launched. Let's look at another example. A diver performs a dive from a high diving board. The parabola shows the height, h in feet, of the dive with respect to the horizontal, d in feet, from the diving tower. So instead of x and y, we're talking about d and h. D representing the distance from the springboard and h representing the height. So, first question, what coordinate will tell you the initial height of the diver? Well, we know that when the diver is 0 feet away from the springboard, the diver must be on the springboard. So we want to know what the corresponding coordinate is when I have 0 and something. Now that would be this point. That's the y-intercept, and our coordinate is 0, 14. So at 14 feet, that is the initial height of the diver. What point will tell you the maximum height of the dive? Well, we know that maximum would be our vertex. And in this case, the vertex is at 323. So that means we have at 3 feet away from the diving tower, the dive reaches its maximum height of 23 feet. What point indicates the distance the diver is from the diving tower when entering the water? So that tells us, we know that at entry, the height of the diver is 0 with respect to the ground. So if I can find out what the d is when we have 0, then we can find out what the distance is. Now that's the y-intercept point. We have 8, 0. So the diver enters the water 8 feet away from the diving tower. Let's look at another example. We have a ball toss here. A ball is thrown straight up. The graph shows the height, h in feet, of the ball and the time, t seconds, after it was released. Now let's look at each coordinate. What's the meaning of the coordinate 0, 3? So that tells us at 0 seconds, the ball is 3 feet high. So that means the ball was released from a height of 3 feet. What's the meaning of the coordinate 3, 0? So we're talking about this point now. Well, at 3 seconds, the ball is 0 feet high. So that means the ball has already hit the ground, or it hits the ground at 3 seconds. What's the meaning of this last coordinate? Negative 0.2 and 0. Nothing. It's not possible to have a negative time. So we're going to call this point inadmissible, and we're going to ignore it. In this question, with the assumption that the ball lands or ends at the ground, we're only looking at the first quadrant. Let's look at another ball toss question. This graph shows the height in feet of the ball, where t is the number of seconds after the ball leaves Tommy's hand. What's the height of the ball at 3 seconds? Well, we know that when t is equal to 3 seconds, we are going to have a corresponding h coordinate. Now, since I can look at the graph and I won't be able to get an exact number, I could use the equation by subbing t is equal to 3 into the equation. So I have h is equal to negative 16 times 3 minus 2 squared plus 80. So let's simplify. Negative 16 times 1 squared plus 80. Simplify again. H is equal to negative 16 plus 80, or finally, height is equal to 63. So we know that the ball is 63 feet high 3 seconds after it leaves Tommy's hand.